Industrial manufacturing operates at the edge of physical volatility. When raw materials are subjected to high friction, heat, or pressure, the resulting byproducts, like fine dust or volatile fumes, require only a single spark to trigger a catastrophic reaction. Controlling this volatility requires strict structural parameters. In India, those parameters are codified in Chapter 4 of the Factory Act 1948. This legislation was drafted to correct the severe vulnerabilities of early industrialization. Early 20th century workrooms maximized production density, placing workers shoulder to shoulder with unshielded machinery and highly combustible materials, meaning a single mechanical failure routinely caused mass casualties. Sections 37 through 41 address this by establishing a multi-tiered protocol. The text demands primary prevention to stop accidents, secondary mitigation to control the damage if prevention fails, and strict administrative oversight to maintain the system. Looking closely, the statute operates as a three-dimensional spatial map, dictating the exact placement and enclosure of physical machinery. Safety professionals use these rules to engineer tangible mechanical constraints, drafting blueprints for pressure vessels, routing exhaust infrastructure, and enforcing rigid operational zones. Translating the law into these physical structures is mandatory. Without precise mechanical compliance, the facility relies entirely on the unpredictable physics of fire and pressure to determine the survival of the workers inside. Section 37, subsection 1, dictates the immediate response to explosive dust, gas, or vapor. It establishes a strict hierarchy of primary prevention triggered the moment a process produces combustible byproducts. The legislation mandates two immediate mechanical interventions. First, the effective enclosure of the specific plant machinery generating the hazard, and second, the continuous removal of the accumulated byproducts. The physical ductwork isolates the combustible material before it can mix with the broader room atmosphere. The third mandatory step under subsection 1 is the total exclusion of all possible ignition sources from that newly enclosed area. However, subsection 2 anticipates failure. It applies to machinery where internal explosions cannot be fully prevented and where the structural casing cannot withstand the resulting pressure wave. To restrict the spread and effects of a blast, the law mandates the installation of specific secondary mitigation hardware, specifically identifying chokes, baffles, and vents. Baffles and chokes alter the internal geometry of the pipe. When an internal blast occurs, these staggered barriers force the kinetic energy to change direction repeatedly, deliberately slowing the velocity of the explosion. Once the velocity drops, vents channel the remaining pressure safely out of the system before the kinetic energy can violently rupture the main structural casing. Section 37 forces engineers to embed physical fail-safes directly into the machine's architecture, acknowledging that primary controls will degrade and the surrounding workers need a final layer of protection. Subsection 3 shifts the regulatory focus. It moves away from permanent structural design and imposes strict operational procedures for interacting with gases or vapors held above atmospheric pressure. Before a worker can loosen any joint or fastening on a pressurized vessel, the law requires an exact sequence of actions. The flow of gas must be isolated by a stop valve, and internal pressure must be reduced to safe atmospheric levels, and the system must be secured to prevent explosive vapors re-entering while the pipe is open. The statute includes a specific geographical exception. This strict opening sequence is legally waived if the pressurized plant machinery is installed in the open air. Placing the machinery outside allows natural atmospheric dispersion to mitigate the danger, eliminating the rapid accumulation risks that exist inside an enclosed factory floor. Subsection 4 governs the application of heat. It expressly prohibits any welding, brazing, or soldering on tanks that previously held flammable substances. To legally perform hot work, a facility must execute mandatory prerequisites. All residual substances must be removed, the fumes must be purged or rendered non-explosive, and the metal must be allowed to cool completely before any new volatile material is introduced. These subsections mandate that the physical properties of pressure equalization and thermodynamics be managed through non-negotiable, repeatable human operational checklists. While Section 37 targets specific machine-level risks, Section 38 scales up to systemic, facility-wide fire prevention. Subsection 1A requires safe means of escape for all persons in the event of a fire. This demands robust, dedicated egress routes that remain structurally sound both internally and externally. Subsection 1b and subsection 2 mandate the physical presence of extinguishing facilities and require management to ensure all workers are adequately trained in the exact routine to follow when a fire breaks out. The most critical regulatory mechanism in Section 38 is found in subsection 4. This grants the chief inspector override authority. If the inspector observes the nature of the work, the construction of the factory, or a special risk to life, and determines the prescribed safety measures are inadequate, they can issue a written order mandating additional custom security measures with a strict compliance deadline. This override clause ensures companies cannot use basic legal compliance to shield themselves from liability if their specific manufacturing process clearly requires a higher standard of care. Section 38 relies on dynamic legal oversight. The safety architecture of the plant must adapt to the physical realities of the site and the active judgment of the inspectorate. Sections 39, 40, and 40A provide the state with a specific three-tiered matrix of regulatory escalation. The baseline power is investigatory. Under Section 39, if an inspector simply suspects a condition is dangerous, they can legally compel the manager to furnish structural drawings or carry out stability tests to prove the machinery is safe. Escalating to the second tier, Section 40, subsection 1, and Section 40A grant corrective power. If a danger or state of disrepair is confirmed, the inspector issues a written order forcing the occupier to execute precise safety repairs or building maintenance before a specified date. The ultimate punitive and preventative power rests at the peak, detailed in Section 40, subsection 2. The legal trigger here is imminent danger. If the condition of the plant involves an immediate threat to human life, the inspector executes an immediate written order prohibiting the use of the building or machinery entirely until properly altered. A Section 40, subsection 2 order halts production completely, imposing severe operational and financial consequences on the facility until the physical risk is neutralized. The inspectorate operates a calibrated weapon. The state responds with escalating force, ranging from mandatory written paperwork requests to a total, absolute facility shutdown. Purely physical engineering controls, the enclosures, vents, and fire escapes, eventually reach their limits. Maintaining a safe environment requires continuous, dedicated monitoring. Section 40B bridges this gap by legally mandating the employment of safety officers, institutionalizing human oversight within the factory's hierarchy. This requirement triggers automatically if a facility employs 1,000 or more workers, or if the state government identifies the specific manufacturing process as carrying a severe risk of bodily injury, poisoning, or disease. The chapter closes with Section 41, which establishes a final legislative failsafe. Section 41 allows state governments to unilaterally make rules requiring new safety devices and measures for any class of factory, enabling the law to adapt to new industrial technologies without rewriting the entirety of the Factory Act. Tracing the path from Section 37 reveals a highly structured compliance journey. It begins at the molecular level, containing combustible gases and managing internal vessel pressure. It scales up through structural fire mitigation and egress planning, arms the inspectorate with escalating enforcement powers, and finishes with the mandated human administrative continuity of safety officers. Compliance under Chapter 4 requires looking past the legal penalties. It functions as an integrated blueprint, fusing structural engineering, operational discipline, and continuous human oversight to maintain the safety of the plant floor.